think we should start. So I'll begin. Hello everyone, and a very good afternoon to all of you joining us from different parts of the world today. A very warm welcome to all our respected authors and invited guests. So, you're now attending technical session 5E with us. So, my name is Yashita, and I'll be your moderator for this session. I'm truly delighted to be here with all of you and looking forward for a very smooth and engaging knowledge-packed session together. So, on behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it gives me a great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. So, this year is a very important year for us. It is the 10th edition of ICTCS and it is being conducted in a hybrid mode. So the physical conference was successfully held yesterday in Jaipur, and today and tomorrow, 16th and 17th, we are connecting virtually. So throughout, uh, so wherever you are joining us from today, thank you for being part of this special edition. So let's make the most of this digital space together. So we have an excellent lineup of presentations scheduled for this session, covering diverse ideas, research, and very innovative approaches. So I hope you'll find today's discussions informative and engaging. So even in an online setting, the exchange of ideas and perspectives will truly bring life to our session today. So before beginning the session, I will give a quick overview of how today's session will run. We have 10 presentations scheduled in this session. Each presenter will be giving 10 minutes for the presentation, followed by a 2 to 3 minutes for question and answers. At the 9 to 10 minute mark, I will give a gentle reminder to the presenters for everyone to manage their time smoothly so that the session will be on the track. So, we kindly request all the participants to stay connected with us until the closing remarks. Your continued presence and engagement add great values to the session. So, if you have any questions or updates during the session, please feel free to share them in the chat box so that I'll be assisting you accordingly. So before we begin with the paper presentations, it's my pleasure to introduce the session chair for this session. We welcome Dr. Ishwari Raskar ma'am, who is an assistant professor at MIT ADT University, Pune, specializing in data science and the Internet of Things. Her research focuses on mobile applications with OCR capabilities, wearable technologies, energy efficient sensor networks, and machine learning based risk assessment. So Dr. Raskar is committed to advancing innovative research and fostering impactful learning experience for our students. So, ma'am, we are honored to have you with us today. We would now like to invite you to share some welcome remarks for the session.
Thank you so much, Yashita. Good afternoon, everyone. It is my pleasure to welcome you to this technical session of ICTCS 2025. So, this conference provides an excellent platform for the researchers and academicians to exchange the innovative ideas and discuss emerging trends in the information and communication technologies. I look forward to insightful presentations and meaningful discussion during these sessions. I wish all the presenters and a productive and enriching this experience. I have a total 15 years of experience in the data science and machine learning. So I'm happy to share my experience with you all guys and welcome you all. Welcome and thank you once again.
Okay, thank you so much, ma'am, for your remarks. So, all right, everyone, let's begin with the paper presentations for the session. So, our first presenter is Divya Bharti, who will be discussing his paper, a review of bacterial hodospin-based bioelectronic devices, principles, and its applications. So, are you there, Divya Bharti? Durable A. The paper presentation is
Yes,
to
ma'am.
be done
Yes,
by
ma'am.
Durable. Yes. So,
And
so you can share the screen, please.
okay.
Mm.
Uh, Good morning, respected chairpersons, distinguished judges, faculty members, and fellow researchers. I am Durevil, a final year undergraduate student from the Department of Mechatronics Engineering, Satyoma Institute of Science and Technology, Chennai. Today, I will be presenting my review and design work titled Review of Bacteriopsin-based bioelectronic devices, principles, and applications. This work explores the use of a light-driven biological proton pump, bacteriopsin, to develop the miniaturized optoelectric biosensor. Then we will start with the introduction. Biosensors are gaining significant importance due to their ability to detect biological, chemical changes in real time. In this work, we focus on bacteriopsin, a naturally occurring light-activated proton pump found in halobacterium cell area. When exposed to light of a specific wavelength, bacteriopsin undergoes a conformational change that actively transports protons across a membrane-like structure. The proton movement can be converted into an electrical signal using the suitable electrodes to enhance the sensitivity and conductivity. A graphene-coated working electrode is integrated into the system. Such biosensors have potential applications in medical, diagnosis, bioelectronics, environmental monitoring, and renewable energy harvesting. Then we will go with the objectives. Objectives of this paper is to utilize the bacteriopsin as a proton pump to generate an electrical signal, then to develop an electrode-based sensing mechanism capable of detecting proton movement. Then third one is to enhance the sensor efficiency using the graphene electrodes and hydrogel coatings. And finally, to explore the potential of the system in bioelectronic and medical application. This is our methodology. This project followed a systematic, structured methodology. It began with a problem identification and an extensive literature review to understand existing bacteriopsin-based devices. This was followed by conceptual design of the sensor architecture. Simulation and modeling were carried out to study proton transport behavior. Since this work is primarily simulation-driven, data collection and analysis involved in interpreting simulation results. Based on these findings, conclusions were drawn and future scope was identified. Then these are the materials and processes. The biosensor design and simulations were carried out using COMSOL multiphysics. The transport of diluted species module was used to model proton dynamics and experimentally reported diffusion coefficients and flux equations. Data from COMSOL, such as proton concentration and electric potential, were collected and analyzed to establish the relationship between proton movement and electrical output. From a fabrication perspective, this design follows a conceptual layer-by-layer approach. This includes a graphene bottom electrode, a bacteriopsin embedded hydrogel layer with pH buffer solution, a transparent ITO top electrode, and a proposed 3D print enclosure for a mechanical stability and light control. This is the schematic model of bacteriopsin photocycle. This slide illustrates actually the photocycle of the bacteriopsin. Upon absorbing the light, the bacteriopsin transitions from its ground state, known as BR570, through a series of intermediate states. During the cycle, a proton is transferred from the cytoplasmic side to the extracellular side of the membrane. This proton transport establishes a proton gradient, which is the fundamental mechanism exploited in our biosensor for the signal generation. Then, for the components of the sensor, bacteriopsin, which is a core element converting light energy to a proton movement. Then the hydrogel layer which facilitates the controlled proton transport and supports the biological material. Then for pH buffer solution, which maintains a stable chemical environment, preventing the signal drift. Then the graphene-coated working electrode converts the proton-induced change variations into an electric signal. Then ITO glass, ITO serves as a transparent top electrode, and in that electrode we will use the silver paste, and through that we will get the electrical signal outputs. The knob amplifiers enhances the weak electrical signals generated by the electrode. Then microcontroller and data display unit process visualizes and the sensor data. ITO glass actually conducts electrical signals while allowing the light through it. Then this is the structural layer of the sensor. As I told, this diagram shows the layer architecture of the proposed biosensor. At the bottom, there is a graphene electrode and Above it, the hydrogen layer PS buffer solution lies. Above that, the bacteriopsin layer. Then again the PS buffer solution hydrogen layer. Then again indium tin oxide electrode. Uh, um, the hydrogen matrix with the pH buffer which stabilizes the environment and supports proton transport. Then actually the bacteriopsin which performs light-driven proton pump. Then ITO top electrode allows the light penetration while enabling electrical signal collection. Then graphene electrode selected for its high conductivity potential and biocompatibility. And then work done. This paper focuses on the design and simulation of miniaturized optoelectric biosensor utilizing bacteriopsin for the detection of specific activity as motivated by its potential medical diagnosis, environmental monitoring, biochemical research. The work encompassed in the followed areas. The biosensor geometry was modeled in COMSOL, optimizing layer thickness and material placement. Then light-induced proton transport by bacteriopsin was mathematically modeled using reported biophysical parameters. The resulting electrochemical signal at the electrode interface was simulated. Then key parameters such as light intensity, buffer conditions, and sensor dimensions were varied to evaluate the performance. This is the MATLAB data analysis and signal processing. Simulation results from COMSOL were exported to the MATLAB for post-processing. MATLAB was used for signal processing tasks such as noise reduction and enhanced signal enhancement. The process data were analyzed to evaluate sensor sensitivity, response time, and stability. This step strengthens the reliability of the simulation-based predictions. Then this is the schematic design of our MCU. This is the PCB design of our MCU. Then this is the COMSOL multiphysics 3D model of the biosensor. Then this is the proton concentration graph which we got in the COMSOL. Then this is the MATLAB schematic circuit which we used to determine which resistor to use and in which homes we want to use that resistor. Then the future work to be carried out. Future work will focus on the refining the biosensor architecture by varying hydrogel thickness, electrode materials, and geometry. More detailed biological models of bacteriopsin behavior will be incorporated. Advanced signal processing algorithms will be developed to further improve signal to noise ratio. Then selectivity of interference analysis will also be carried out to evaluate the real world adaptability. Then the conclusion is, in conclusion, this work demonstrates the feasibility of bacteriopsin-based optoelectric biosensor through the schematic design and simulation. The results show a strong potential for applications in bioelectronics and medical diagnostics. The simulation-driven framework provides a solid foundation for future experimental validation and device development. Thank you for your time and attention. I would be happy to answer any questions.
Okay, so my first question is explain me the role of BR in the bioelectronic devices and how it will be work into the photocycle enables light to chemical energy conversion. Is there any solution or will
Can you repeat the question once? The role of VR in
bioelectronic devices and how it will work in the photocycle enables light to the chemical energy conversion. How it will convert the photocycles to the light to chemical energy conversion.
Yeah, actually, in bacteriopsin, it's the bacteria inside the bacterium protein inside the bacteria. Bacteriopsin plays a central and enabling role in bioelectronic devices because it can able to directly convert optical energy to electrochemical and electrical signals. Since when the protein changes its orientation, it actually enables the when it actually gives a it actually emits the electrical signal, so it is known as photoelectric conversion, and it's unlike the conventional electronic materials, BR operates efficiently at room temperature in aqueous environment and saline environment at extremely low power levels, making it exceptionally suitable for bioelectronic integration.
Okay. And what is the importance in the BR layer preparation methods in the computational simulations?
The importance of BR layer preparation.
Methods in computational
Okay.
simulation.
Mm.
Your voice is not clear.
Mm. Actually, the importance of BR layer preparation in console is actually its representation of the BR layer in console multiphysics is a critical step which is actually simulated by the behavior of bioelectronic devices and that rely on the light-driven proton transport. Since BR is active biological element responsible for proton pumping and signal generation, the way it's modeled directly determines the physical relevance, numerical stability, and predictive capability of the simulation results. In console, the BR layer acts as a primary source of proton generation under the optical excitation. Properly defining this layer ensures that the stimulated proton flux reflects the real photocycle driven behavior of bacteriodopsin rather than an abstract or idealized source. Uh,
Okay. Okay, that's okay from my side.
okay. Okay.
Thank you.
Okay. Thank you.
Thank you, Duraival, for sharing your idea. Now, next up, we have Aarti Jain and Nikita Bhatt, who will be presenting the paper titled An Experimental Study of Deep Learning Models for Brain Tumor Classification in MRIs. So, is
Ma'am,
Aarti here in the meeting?
yes, ma'am.
Yes, so you can share the screen and begin with the presentation. You'll be having 10 minutes.
Okay.
Yes.
So, good afternoon, everyone. Myself, Aarti Jain, with my co-author, Dr. Nikita Bhatt, we are privileged to present our paper on experimental study of deep learning models for brain tumor classification in MRI. So, our research focuses on a comparative and systematic evaluation of deep learning architectures for automated brain tumor classification using MRI images. So, this is the outline of the presentation. So, brain tumor are among the most critical neurological disorder where early and accurate diagnosis directly impact the treatment planning and patient survival. MRI is the preferred non-invasive image modality due to its excellent soft tissue contrast. However, the manual interpretation has several challenges. As it is time consuming, subjective in nature, and prone to have inter-observer variability. Recent advancement in deep learning, particularly in CNN, have demonstrated strong potential in automating the medical image analysis by learning descriptive features directly from the raw images. So this motivated us to investigate which deep learning model architecture perform best under different classification complexities, binary tumor detection versus multi-class tumor subtype classification. So the data set, so our primary object for this research was to develop an automated consistent brain tumor classification system where we have compared three architectures, a custom CNN, a ResNet 15 and an efficient NetBio. The dataset used for this is the publicly available dataset on Kaggle. One of them is binary dataset, which have two classes, a healthy and versus tumor, which have each have 500 images, which is splitted into training and testing sets. The other two are multi-class datasets. One of them have 2,500 MRI images, which is distributed in four classes, which have glioma, meningioma, and pituitary and healthy. And second one also, second multi-class has also validation data set for the same four classes. So we have used the to improve the generalization and prevent overfitting. We have applied image resizing, normalization, data augmentation techniques such as rotation and horizontal and vertical flipping. Also, augmentation was performed on the fly during training, ensuring diversity in training samples. Let's see the model architecture. So for the custom CNN designed specifically for the medical images, we have used three convolutional blocks with increasing features of 32, 64, and 128. Each block includes convolutionary level 2D, batch normalization, ReLU activation, max pooling, and fully connected layers with dropout of zero point 0.5, approximate of 1.5 million parameters. Its key advantage was it was lightweight, well regularized, and task specific. The second one was ResNet 50, which is a pre-trained on ImageNet. Final classification layer was is replaced here, and top 30 layers unfrozen for fine tuning. Dropout added before output layer, and the key advantage of this was the powerful feature attraction and depth. Third is ImageNet BO, which is prenet, also prenet on ImageNet, custom classification head, progressive layer unfreezing, and it has 5.3 million parameters. Its key feature is optimal trade-off between accuracy and computational efficiency. All models were trained under identical experimental condition to ensure a fair comparison. So we have done the hyperparameter tuning and training. We have done grid search comprehensively with three different optimizers, just such as ADAM, SDG, RMS prop, different learning rates, dropouts, and batch sizes, total combinations, different total combinations, maximum epoch of 20 to 30 with minimum early stopping of patients of 5 to 10 epoch, L2 regularization, and five-fold cross validation. So the results were for the binary classification. ResNet 50 has achieved the best performance. Accuracy was up to 94%. Pre-trained model benefit from strong low-level and mid-level feature representation. For the multi-class dataset 1, we have custom CNN consistently outperformed pre-trained models with an accuracy of 90%. Here, ResNet 50 has showed some overfitting. EfficientNet offered a balanced performance. This result demonstrated that larger models are not always better, especially with the limited medical data. This was the multi-class dataset 2 result, where also the CNN has performed well rather than the ResNet and EfficientNet. So analyzing this, we have come to know that pre-trained model excel in simpler binary tasks due to transferable features, and custom CNN performs better in complex multi-class scenario, due to reduced parameter count, better regularization, and task-specific design. This highlights the importance of matching model complexity to the task complexity. The limitations were such that we have some limited data set size, a single MRI modality, and no clinical metadata integration, no real-time clinical validation. Our future work includes the vision transformer hybrid CNN transformer model with a self-supervised learning, clinical deployment, and federate learning for privacy-preserving training. To conclude this, in conclusion, our model choice depend on the task complexity. ResNet 50 is best for the binary tumor detection. Custom CNN is superior for tumor subtype classification, and EfficientNet BO offers a balance between performance and efficiency. Our approach provides practical deployment insights, especially for low resource healthcare system. Thank you for your attention. I will now be open for the questions.
Thank you so much, Arati. My question is how the evaluation metrics used to assess the deep learning model in the brain tumor classification.
So for the binary classification, we have accuracy primarily for the evaluation metrics. But where we have used the CNN, we have kept the different evaluation matrices, just such as precision, recall, F1 score.
How the matrices will reach to the accuracy? How much accuracy will give up to the reach the accuracy? How much accuracy?
So for the binary classification, we have gone up to 94%, and it can be improved with further augmentation and normalization. And for the multi-class, we have custom CNN, which we can modify with which had some overfitting issues. So we can modify it to make accuracy up to 94. Currently, it is 92, 92.
Okay.
Okay.
Thank you.
Thank you.
Thank you so much, Aarti, for sharing. Now, next up, we have Samarth Dikshit, who will be presenting the paper titled Automated Sample Tube Sorting System for Diagnostic Centers. So, is Samarth there?
Yes, ma'am.
Yes, you can share the screen and begin.
No, it says someone else is sharing.
I'll stop it.
Okay. Good afternoon, respected panel. Today I am here on behalf of my team to present our work, Automated Sample Tube Sorting System for Diagnostic Laboratories. Our team consists of me, Samar Dikshit, and my fellow classmate Kamlesh. Both of us are students at PS University, UCE department. Throughout our project, we have been guided and mentored by Dr. Ananda and Prahlad sir. This is our agenda for today. I will go through it one by one. So our problem statement is basically to reduce the turnaround time in diagnostic laboratories so that the patients can receive blood test reports sooner. So currently samples are sorted manually, which takes a lot of time. So our project aims to design and develop an automated blood test tube sorter to reduce the turnaround time. As you can see, each laboratory gets the tubes like this, and they have to be manually sorted based on cap color, and the barcode has to be scanned manually. Small labs get around 200 samples per day, but large laboratories get around 12,000, 15,000 samples. A person working continuously can sort around 200 to 300 tubes per hour, which means it takes 10 people to takes 10 people 5 to 6 hours to sort all these tubes, which is a lot of time. And this is why the blood tests are delayed and usually get them the next day. So this is our methodology of sorting the blood tubes. So the cap color indicates what type of test has to be run on the sample. For example, red can mean general test and purple is hematology test. And the barcode has information about the patient such as name, age, what test he's undergone, patient ID, everything. All these should be scanned to store in a database for further reference. So this is a proposed model. So this is the blood tube holder from which it dispenses onto this conveyor belt, which is carried to this crevice where the tube is rotated until the barcode is on top. The camera module placed here will scan the cap color and the barcode and provide information to the servo motor to adjust the ramp accordingly based on color. So once it is sorted, then the tube moves forward and then is sorted into respective boxes based on the color. So this is our flow. So we're using the Raspberry Pi microcontroller to handle all the software and image processing aspect. Using a Raspberry Pi camera module and a barcode scanner to identify cap color and scan the barcode information. We're using OpenCV and Python modules to decode the color barcode information. We have a rotation module, which is all the hardware is controlled by an Arduino board, which is connected to the microcontroller. So all the motor, servo motor, and the rotation module get information from the microcontroller based on the cap color scan, and these perform the necessary actions. So as you can see, these are our results. So on an average, we found that it takes 8 seconds when 6 tubes are sent back to back for the sample to be segregated. This means we can sort around 450 tubes per hour consistently without it taking breaks in between or without it. So this is more efficient and reliable than manual sorting. So in conclusion, that if automation is introduced in diagnostic centers, Even now, despite technology advancing so much, all this work is done manually, and it takes a lot of time, and it's a very tiresome and cumbersome process. If automation is introduced in diagnostic laboratories, we can significantly reduce the turnaround time, which will in turn help the patients by receiving the test results faster, and it will help the patient. These are our references.
Okay, Samarth, how many references you use here?
Not many,
Hmm?
not many. So we didn't find anyone who has done a similar project before, so we didn't have many references to use.
Because your last paper is 2015, right?
Yeah.
So use the latest paper. Okay. So which are the technologies you are used here in the automated sample tube sorting?
So we are using an Arduino board to control the motors, servo motors, and all the hardware aspects. And we're using a Raspberry Pi to handle the image processing part, and we're using Python and OpenCV to perform the image processing.
When we improve the efficiency or the accuracy in the diagnostic center, so what are the principal models or the automated samples are used to improve the accuracy in the diagnostic center?
So to improve the accuracy, because the sorting process is manual now, and it's a very tiresome and repetitive process, and because it's manual, like human error is always possible. So we were trying to minimize that while also giving more efficiency and sorting it faster.
When the efficiency or accuracy will be covered, at that time, how the impact will be given to the reduction process and the laboratory workflows?
So right now, all this time, so this has to be done first, and then the tubes are sent to the respective test places to run the respective tests. So if this time itself is taking so long, then the entire test is delayed. So if we can reduce this time, then our entire turnaround time will reduce, and in turn, it will help the patients and make the laboratory flow smoother.
Okay, thank you, Samarth.
Thank you.
Yeah. Thank you so much for presentation. So now next I'll be inviting. Okay, so next I'll invite Amir to present his paper titled Building Responsive UI in Full Stack Applications Using Tailwind CSS and React. So is Amir here? Are you guys ready? He is in the meeting. Uh, Anybody from his team is able to hear me? Okay, till then we can start with the next paper. So for the next presentation, we have
Hello.
Bhumi Barotia. Yes, Amir, are you there? Amir,
Hello.
can you hear me? Are you ready with
Can't
the
hear you.
presentation, Amir?
Mm.
You can share the screen, Amir.
Yes.
You can share the screen, please.
Good afternoon. My name is Amir Khan, and I present my presentation on behalf of my team. And research
Your
paper
screen is
code
not
is
shared.
951, and our topic is building responsive UI UX,
Amir, your screen is not visible
Screen
and
is
your
not
and the
voice
full
is
visible.
not
stack
clear.
applications using the Tailwind,
Yes,
CSS,
Amir,
and
am I
React.
audible to you?
Just a minute.
Amir, you are not audible properly.
And the screen is also not shared. Please share the screen first. Present the presentation.
So building building responsive UI UX full stack using applications, Tailwind, CSS, and React. This is combination create an industrial standard for the building scalable, high performance web applications. Uh, the device diversity, we no longer live in the world just desktop and the
Amir,
mobile. We must
your
the
presentation
account
is
for the
not there.
smartphones, tablets, large desktop monitors, and even the emerging wearable technologies like meta glasses.
Yashita,
Yes, ma'am.
we can start with the next presentation because Amir's
Yes.
audio is
हेलो,
not.
अरे मैं तो एक
Yes.
प्रेजेंटेशन दे रहा हूँ.
Your
मैंने शेयर किया है ना
presentation
अभी.
is not. No, your
अबे
presentation
यार,
is
सच में नहीं
not
हो
visible.
रही.
Your
अबे
voice is not clear, Amir.
मेरी मेरी आवाज ही नहीं आ रही ना अभी तो.
Your
अरे
voice
मुझे
is
नहीं आ रही
not
ना आवाज
visible
इसकी.
and your presentation is not shared, Amir.
चल ठीक है, मैं
Hello, Yashita.
Yes, I'll start with the next
क्या बोलूँ, मैं चैट
Yes,
presentation.
करूँ?
yes, yes.
Hmm.
Ma'am, can I start? Yes, Bhumi, you can start the presentation. Ma'am, is it visible?
Yes, it's
Yes, it
visible.
is visible. Your voice is cracking a bit. Please check with your internet connection and then start.
Oh, ma'am, just give a minute.
Yes.
Start with the first slide.
So, good afternoon, everyone. I am Bhumi Barotia and from IRA College of Engineering IT, and today I will be presenting our research work titled Creating Engaging Interfaces with Unity UI and audio integration. The paper focuses on how proper UI architecture combined with synchronized audio feedback can significantly improve user experience, scalability, and maintainability in Unity based application. So, the real time problem statement solution. The problem statement is that Unity projects often suffer from poor UI architecture, commonly called spaghetti problem. Game logic, UI visuals, and audio are tightly coupled, making changes difficult and error prone. UI updates and audio feedback are not properly synchronized, increasing cognitive load on players. And lack of scalable architecture pattern reduces maintainability, testing capability, and usability. So the problem identify mainly in poor UI architecture and tightly coupling between game logic, UI components, and audio system. It makes difficulty in making changes or scaling features, and it was unsynchronized UI updates and audio feedback. It was also low maintainability and testing capability. So the proposed solution was to use a MVVM model view model design pattern in Unity to separate the clear content clearly, implement unidirectional data flow, integrate event-driven audio feedback, use Unity change event system for real-time synchronization. So we do not just improve UI appearance, we improve architecture using user cognition and scalability also. So the introduction. User interface design plays a crucial role in enhancing user engagement and overall experience in interactive applications and games. Unity provides a powerful UI system that enables developers to create dynamic, responsive, and visually appealing interfaces, along with visual elements and audio feedback significantly improve user interaction by providing the immersive and intuitive response to user action. However, poorly structured UI logic and unorganized audio handling can lead to an hard to maintain system. The research focused on integrating UI with effective audio system using structured design approaches to create engaging, interactive, and user-friendly interfaces. The proposed approach improves usability, maintainability, and overall user experience. So the technology which I used in this are Unity Engine, Unity UI Toolkit, C# programming language, audio system, and MVVM model view architecture. The Unity game engine is used to design the interactive user interfaces and manage game and application logic. The Unity UI system used to create a responsive and visually engaging user interfaces for users, and the C# programming language used to implement UI behavior, handling and audio control logic, and the audio system we use, it used to integrate effects and background music to enhance the user experience more. And the event-driven MVVM architecture used to separate UI and improve the maintainability and scalability. So Unity provides a powerful UI tools, but without architectural discipline, project quickly become unmanageable. Our work focuses on how to use these tools correctly. About the topic. So the main concept about this is Unity UI creates interactive elements such as button, menus, sliders, and panels. Audio integration provides click sound, hover feedback, background music, and action-based cues. Together, it can create an impactful UI and audio create immersive, intuitive, and user-friendly experience by reducing reliance on visual cues alone. The key feature of technology. First, Unity Canvas system. It is used to design responsive UI element like menus, panel, and text. The second one is interactive UI components. It will help in building components such as button, toggles, and image for user interaction. The third one is audio source and audio listener. It help in enable background music, sound, and real-time audio feedback. The fourth one is event-based audio feedback. It's sound triggered on UI actions like hover or notifications. And UI animations and transition for smooth animation and visual effects provide to user. And the cross-platform support, it helps mainly for to consistently work across mobile, desktop, and web platform. Its scalability and microservices. Unity handles the interactive UI and audio locally while backend service manage data and processing efficiently. The system can support more users by scaling backend service without changing the Unity interface. Different functionalities like login, audio assets, and user preference run as separate microservices. Each microservice can be updated or scaled independently without affecting the overall application. So in real time problem statement solution, in many games, an interactive application user experience poor engagement due to unresponsive UI element and lack of audio feedback, especially when multiple users access the system simultaneously, leading to delays and performance issues. These problems reduce user satisfaction and make the application feel slow and unreliable. Complex UI layout without proper optimization can cause frame drops and input lag. Delayed audio responses confuse users to reduce immersion. The solution which we take was using Unity UI for optimized interface design and integrating audio feedback user actions improve interaction, while a scalable backend with microservices handle user data and audio access efficiently, ensuring smooth real-time performance and a consistent user experience. Real-time web application in this. A Unity WebGL based interactive web application with dynamic real-time audio feedback. User can interact with menus, settings, and control that respond instantly with animations and sound. Real-time backend services handle user login, preference, and authentication asset deliveries. Microservices manage different functions like authentication and content update independently. The system supports multiple users simultaneously without UI layout and audio delay. Scalable architecture ensures smooth performance during peak users. So why we should use this technology? So Unity UI is used to create interactive, visually appealing, responsive user interface easily. Audio integration provides instant feedback and improve user engagement and immersion. The technology provides a real-time interaction with smooth performance across platform. Microservices allow better scalability and handling of multiple users simultaneously. It enables faster development, easy updates, and better maintenance of the application. For authentication of this technology, first there is user login and registration in which the user will log in. There is secure sign up and login system for users. The second, the token based authentication will be there where we will use JWT or authentication tokens for session management. The third one is authentication microservice. It handles all the authentication tasks independently, so it is secure. The fourth one is secure access control. Only the authenticated user who have been logged in access the Unity UI features. And there is the last one. Through all these features, the data privacy and security will be enhanced and protect the user data and prevent unauthorized access. So for concluding, I want to say like to conclude our research demonstrated engaging interfaces are not just about design but about architecture also. By combining Unity AI, MVVA, unidirectional data flow, and event-driven audio integration, we achieve scalable, maintainable, and immersive real-time application. This approach bridges the gap between software engineering principles and game development practices. At future scopes are integration with AI-driven UI updation, use behavior analytics, advanced haptics and spatial audios, and connect with the real-time systems. The references I have been taken are these: Unity technology, Unity documentation, MVVM architecture platforms, and these are. Thank you so much for your time and attention. I would be happy to answer any question from your side.
What are the challenges and best practices are involved in synchronizing the UI interactions with the audio element?
Okay. Um, mm, the challenges in audio for synchronizing were the challenges. So the main challenges in audio synchronization include timing mismatches, tight coupling with UI logics, and inconsistent updates and performance overhead. If audio is not synchronized properly with UI and game state, it can break immersion and increase cognitive load for users, as many users when log in.
Okay. What is the role of audio feedback to enhance the Unity-based interface?
Ma'am, can you repeat?
What is the role of audio feedback in enhancing the Unity-based interface?
Okay. Mm. So the role of audio feedback to enhance the Unity based interface to uh, is to audio feedbacks play a crucial role in enhancing Unity based interfaces by providing instant non-visual feedbacks that improve the usability, and mainly it improves the responsiveness and user engagement. It complements visual UI's element and help user to understand system and responses more betterly.
Okay. Okay, thank
Okay.
you.
Thank you so much, ma'am. It was really nice to.
Okay, so next up we have Kushank Arora with us, who will be presenting their work titled Dark Mode and Accessibility in Modern Web Design, a comprehensive analysis of usability, energy conservation, and inclusive implementation. So, Kushank,
Yes,
are you ready?
yes,
Yes.
ma'am.
So share the
Good afternoon,
screen.
all. Myself, Kushank Aroda, and
First, share the screen.
yeah, ma'am, sure.
Yes.
Can you stop sharing so I will be, yeah.
Yes.
Is it visible, ma'am?
Yes, visible.
So here is the topic is about, ma'am, my dark mode and accessibility in modern web design. And my team members are Lavesh Sharma, Vijay Agarwal, Lucky, and with the mentor we are having is Dr. Vishal Srivastava sir, Dr. Akhil Pandey sir, and Mr. Amit Kumar Tiwari. And I am from the RA College of Engineering and IT.
Please keep in mind you have 10 minutes.
I'm sure. And it's not. It's not. Wait a minute. Yeah, the abstract. The abstract is gives the summary of the entire research. But I would like to explain it first because it would be more easy to understand what the things how happen in it. The claims include that the dark mode is widely used in modern UIX design. For the many people believe it reduce eye strain, save batteries, and improve user experience. The research analyzed dark mode from the three major main perspectives is usability, energy efficiency, and accessibility. The thing is, the energy saves mainly occur on the OLED displays, and light mode is more better for reading and comprehensions. Dark mode is cause accessibility issues, especially for the user with the astrometries, and the some research concludes that the dark mode should be not forced but must be optical and context free for the better understanding and for the reading the things on the screen. Here is the introduction. The dark mode has become a standard feature in the most operating system like Android, iOS, Windows, Mac, and many web applications. Study shows that the 70% users on today's in use prefer dark mode mainly because it's modern and attractive. It feels more comfortable at night. Users believe it saves battery, and other than that, it is quite easy to use like in modern world. However, these preferences are often based on the perception rather than scientific evidence. Therefore, this is a standard need to evaluate dark mode in usability and energy. The liter the next is literature review. The literature review explains that the discussed findings from the major research studies, light mode improves reading and speed comprehension, especially for the long text. Like dark mode reduces glare and feels more comfortable in low light conditions. On LED displays, dark pixels consumes less power, so the dark mode saves energy. And LED displays, the backlight remains on same, and the energy savings are minimal. Accessibility research highlights problems such as poor contrast and health effects for the estimation users. The research gap is explained. All the many studies explain they usually focus on only one aspect, such as usability, energy, and accessibility. Unified evaluation covering all three factors together accessibility, concerned, implementation strategies, clear design frameworks for inclusive dark modes. Here's the problem statement. The core problem addressed in the research is that how dark mode can be implemented in a way. So, key challenges is energy saving depends on the type of display. Dark mode creates accessibility issues for some users. Single theme cannot be suited for all users. Some everybody have its own perspective of using the phone and the screens. So the proposed methodology is the research uses a comparative analysis between light mode and dark mode. Key evaluation parameter includes readability, task performance, power consumptions, and accessibility compliances. The study compares performance on LED displays and OLED displays. We see AG 2.1 accessibility guidelines are used as the reference standard. The another I would like to explain the methodology is the eye strain and visual compact, health relation effects, and user brightness adjustment behavior. The methodology includes a review usability experiments, studying power consumption and measurements. Although fields are combined into practical design, recommendation, and implementation checklist. The result and discussions. Explanation says that usability results show that write mode provides better reading and comprehension. User complete tasks faster in light mode. Dark mode performs low light environments, aesthetic appeal, and energy results shows that OLED space save 40 to 60% power in dark mode. LED space shows negligible energy savings. And other is accessibility shows halation effects, blurred text, and for the estimation users in the dark mode. High contact issues negative are lazy users, low vision users. Comprehensive analysis is the better readability, better accessibility, suitable for the long reading and daytime uses. The dark mode offers improved eye comfort in low light environments, often preferred for the aesthetic appearance. And from a accessibility perspective, light mode is more concerned across the different group modes, can create challenges for the user with some disease of the low vision in that. Conclusion I would like to explain that the study concludes that the dark mode is usually universal superior. It affects depend display technologies, light conditions, user visions. So adaptive intelligent themes. It depends on the person on the thing which he was to use. And OLED displays it's quite often used in it. And here are some references we have used. So that's all about our presentation, and thank you for your time and patience. I'm here to answer any questions if you have.
Okay, how many papers you have referred?
Like, ma'am, there are 5 papers we have referenced. It was in 2018, 19, 20, and 22.
Okay, so the last paper is 2022, right?
Yes, ma'am.
Okay. So what are the challenges and best practices are involved to implement in the dark mode design in modern web application?
Like, ma'am, majorly the challenge is the depends on the person. If the some person is having the low eye sights and is not able to see the things, so is that a major challenge to implement that in those things.
Okay.
Yeah.
What is the role of dark model in the energy conversion?
Like, ma'am, like we if like everybody use dark mode, and we suddenly when we start dark mode, the it blanks the background like in a black color, so it helps to for the battery consumption, ma'am.
Okay.
Yeah.
Okay. Thank you.
Thank you, ma'am.
Okay, thank you, Kushank. For the next presenter we have is Bali Thorat to present her work titled Emotion Aware and Explainable Chatbot for Human AI Collaboration. So, Bali ma'am, are you there in the meeting?
हाँ भाई, सही है, ठीक था ना?
Kushank, will you mute yourself, please? Bali ma'am, are you there? Okay, then while we set up for this presentation, I'll invite the next author, which is Kalinka Kalionova and Pavel Genevsky, to present their paper titled High Resolution Multispectral UAV Imagery for Sunflower Field Scale Monitoring. So, Pavel, are you there in the meeting?
Yes, I'm here. Can you hear me?
Yes, you can share your screen, please, and start the presentation.
Can you see my screen now?
No, not yet.
Now, do you see it?
Yes, it is visible.
Okay, thank you.
Hello, I'm audible.
The topic of my presentation is high-resolution
1 minute,
multispectral.
Pavel. Bali ma'am, after this we will take your
Yes,
presentation, please.
yes, ma'am, yes, ma'am. Thank you.
Pavel, you can continue.
Okay, my topic is high-resolution multispectral UAV imagery for sunflower field scale monitoring. This has been done in the Sofia University in Bulgaria with the collaboration from the industry as well. The agenda for the presentation is to look at the field scale monitoring problem, especially in the context of sunflowers, then the role of multispectral imaging and vegetation indices in agriculture, existing data sets, the goals of the study, the data collection method that we use, data description, data utility, and then conclusion and questions. The field scale monitoring has the following objectives and challenges. Plant growth and density in the early stages of crop development require timely monitoring to provide positive management potential for the yield potential. Monitoring provides essential information for identification of management zones related to fertilization, irrigation, and pest management, and it also facilitates the evaluation of ripeness and the selection of the appropriate time of harvest. Traditional manual monitoring methods are laborious and difficult to apply on a field scale, with typical field sizes from 50 to 100 hectares. Satellite imagery is an alternative that provides coverage over large fields, but it lacks spatial resolution and suffers from cloud cover and long revisit times. This is what we observed for the Sentinel-2 satellite system. In contrast, modern integrated UAVs with multispectral cameras provide a viable monitoring alternative with desirable operational characteristics like better resolution and revisit times. Multispectral imaging is an important method in agriculture. In this method, each pixel measures the reflectance and sparse narrow spectral bands that are sensitive to vegetation. The most prominent spectral bands are in the visual and near-infrared spectrum with typical widths of 10 to 30 nanometers. One big challenge that negatively affects interoperability is that the center wavelengths and bandwidths are not standardized. But for the UAV that was used in this study, we have noted here the exact central wavelengths and the utility of each band. So the blue band is 450 and it is sensitive to leaf pigments, flowers, and it's mostly used in in fruit-bearing trees. The green band, 560 nanometers, is very widely used to assess canopy vigor. The red band is also very useful because it is absorbed by chlorophyll and provides a good contrast to near-infrared. The red edge is not so widely used, but still useful because it's highly sensitive to changes in chlorophyll concentration for differential studies. And near-infrared is very useful because it's strongly reflected by healthy vegetation and provides a very good contrast with the red band. And those two bands, the near-infrared and red, are the most commonly used ones in the so-called vegetation indices formulae, which provide a quantitative evaluation of the intensity of vegetation. One of the most commonly used indices is the NDVI with this formula, and there are also some other indices that are specialized for different conditions, and the ones that we mostly used in our study are the soil adjusted vegetation indices, because when the sunflower field has to be observed during the early stages of development, there's a lot of soil. The challenges with existing data sets for a large field scale monitoring are the following. To build an algorithmic base, data is required of sufficient quality and quantity, and quite often this data has to be tailored to the particular use case. For example, for plant density estimation, you may need one kind of data, and for other studies, maybe the resolution doesn't have to be so precise, and so on. And after exploring some existing data sets in the literature, we identified these challenges. Mostly, data sets are not published. There are papers that describe results, but very often the results are the data that was used to achieve those results is not published. Then even if it is published, it often has some restrictive or unclear license that hinders collaboration with commercial entities. In many of the cases, the researchers that gather data used only RGB cameras, and this is understandable because multispectral imaging is quite expensive and has only recently fallen in price. Another challenge we noticed was the low spatial resolution. Many studies only collect aerial data on which the individual plants are not distinguishable, so it's not usable for tasks such as object detection and other computer vision tasks. And the last but not least challenge is that most of the data that's been published has a limited time span and only covers 1 or 2 days, which is not sufficient to get a sense of the distribution of the data for some tasks. Because of this, we had the goal to collect and publish high-resolution multispectral imagery that is suitable for tasks such as early-stage field scale monitoring of sunflower crops. Emphasis has been put on collecting data in a commercial setting, an actual farm, not an experimental field, using emerging low-cost multispectral UAV technology. By low cost, I mean something like 10,000 euros and not the 70 or 100,000 euros that we had just 5 years ago. The data post-processing and auto-rectification also was one of the goals. We did thorough validation of the data to make it trustworthy and accessible as it is to researchers. And then we specifically selected a publishing license, Creative Commons CC BY 4.0, to provide the data on the clear terms and foster collaboration with both the academia and the industry. The data collection methods that we used was to select a couple of fields near Sofia, the capital of Bulgaria, and we observed them during early and active vegetation. Observations were performed with DJI Phantom 4 multispectral UAV, which is equipped with a gimbal-mounted 5-band multispectral camera, as already described. It also has a GNSS and RTK positioning sensor and an onboard spectrometer for calibration. Data was collected with the nadir-oriented camera position in hover and capture at point mode, resulting in one 8-bit RGB image and 5 16-bit single-band images per shot. We've flown several types of missions, sparse low-altitude missions that only cover points on the field from varying altitudes, but also dense aerial missions from higher altitude that cover densely the whole field. And those were flown on the same day, so that data is comparable. And dense data was post-processed with the DJI Terra software for auto-rectification and light correction. This is a typical camera output in the visible RGB bands, the regular camera, and this is one of the spectral bands that are calibrated in the red part of the spectrum. The data that we collected consists of two data sets. The first one is two-faceted. It has low-altitude sparse images and high-altitude dense images. Total data size 37 gigabytes. And the field is relatively small, 2.5 hectares on 12 dates. The primary purpose of this data set is early stage plant density estimation. The second data set that we collected on the next year is actually three-faceted and consists of a lot more data, because we realized that we need low altitude dense coverage of the field for validation, so that each and every single sunflower plant can be counted and then used as a validation data for estimation algorithms. Both datasets are published under Creative Commons license, as I already mentioned, and are available on the Hugging Face platform. The data utility is to enable the development and validation of algorithms for early stage sunflower density estimation, but additionally it can be used for tasks such as computer vision, classification, object detection, segmentation, and object tracking, for development and evaluation of machine learning algorithms on multispectral imagery, plant counting and phenotyping, spectral characterization, and also comparison with satellite data, experimentation with vegetation index formulae, and also spatio-temporal analysis. The results, as I already described, consists of two UAV-based agricultural imaging datasets that were collected to aid early-stage monitoring of sunflower plants. Dense aerial data was post-processed for auto-rectification and calibration with DJI Terra, and validation scripts were developed and published along with the data, so that data quality can be ensured when someone downloads the data. The datasets were published on those links on the Hugging Face platform. Thank you, and now you can ask questions.
So the data set is already published, Pavel, right?
The data is published. Yes, you can even download it right now if you go to Hugging Face. It is very popular. It has maybe at least 1,000 monthly downloads per dataset, some even more.
Okay. How early stage UAV data can enhance the decision making in this sunflower cultivation?
Sunflower density estimation is a very important problem because the farmer has to make a time-critical decision whether to plow and reseed the whole field if the plants have not emerged sufficiently. So this is our main value proposition, to provide data for the development of reliable plant density estimation algorithms that can provide farmers with timely feedback for decision making.
Okay. How does the UAV-based multispectral imagery supports in the early monitoring of sunflower?
Multispectral imaging is very important because in the early development stages, sometimes plants are very small and very hard to distinguish on the bare soil. And multispectral imaging, especially the soil-adjusted vegetation indices that require near-infrared imaging, are very sensitive to those small plants and provide better contrast for vision algorithms.
Okay, thank you. I will.
You're welcome.
And thank you so much, Pavel. Now we will continue with the remaining presentation. Bali, ma'am, are you there?
Yes, ma'am. I'm audible, ma'am?
Yes, you can begin with your presentation, please.
Yes, ma'am. I will share my slide. Is it visible, ma'am?
Yes, it is visible.
Yes, ma'am. Thank you. Good afternoon to all. I am Dr. Bali Thorat from Dr. GYP College of CS and IT. And my today's presentation topic is emotion aware and explainable chatbot for human AI and AI collaboration. These are the content of my presentation. First, we will see some basic points of emotion. Emotion plays an essential role in how we think and communicate with others. They impact our views, guide our action, and shape the way we relate to people around us. They influence our decision, our problem-solving method, and how we perceive information both. Emotion is a complex psychological state that involves a combination of feelings, thoughts, and behavior. They help people express internal states such as happiness, anger, or sadness through language, tone, and behavior. Currently, as artificial intelligence is widely used in our daily life, the demand for machines that are not only intelligent but also understand emotion has increases. Incorporating emotion recognition into AI system can make interaction between humans and computer more natural, flexible, and interesting. For example, emotion-aware system can identify student distress or frustration and provide them with the personalized support in education. Similarly, assist in healthcare by identifying patient communication difficulties or enhance customer service by responding to customer emotions. Let me start by discussing the motivation behind this work. In today's world, human AI collaboration is becoming most common, whether it's through chatbot, digital assistant, or automated system. For this interaction to be truly effective, the AI system need to demonstrate trust, empathy, and transparency. However, most traditional chatbots are purely rule-based or rely on surface-level responses. They cannot understand the user's emotional state or provide explanation for their action, which often leads to user frustration and reduced trust. So the goal of this project is to design and build a chatbot that can not only detect user emotion accurately, but also explain its reasoning behind each response, all while remaining lightweight and efficient enough for real-world deployment. This approach aims to make AI system more human-like, transparent, and emotionally intelligent, improving collaboration in areas like healthcare, education, and customer support. Objective. First, we develop an emotion-aware conversational agent using a fine-tuned version of DistillBird. The chatbot is capable of detecting 5 fundamental emotions such as joy, anger, sadness, fear, and neutral from user input, which help it respond in a human-like and more and context-sensitive manner. Second, we introduce an explainability mechanism by integrating confidence score into the prediction. This not only informs users about how confident the model is, but also support transparency and trust which are essential in human AI interaction. Finally, our system features a lightweight and practical design, making it efficient enough to be deployed in real-world environments like healthcare, education, and customer support areas, where both accuracy and clarity are equally important. Together, these three contributions demonstrate how emotion-aware and explainability can coexist in a compact, effective, and user-friendly chatbot. Methodology. Our proposed chatbot is built around three core components, that is dataset preparation, model fine-tuning, and system integration. We will see one by one all these three. First, we will see dataset preparation. We use the Go Emotion dataset developed by Google in 2020, which originally contained 27 fine-grained emotion categories. However, to simplify the model and make it more efficient, we condense these 27 emotions into 5 primary categories. That is, just we have discussed joy, anger, sadness, fear, and neutral. We also perform data cleaning and balancing to remove noise and ensure that each emotion category had a reasonable number of examples for training. This pre-processing step helped the model learn emotional patterns more effectively and reduce bias during prediction. Next is model fine-tuning. In this phase, we fine-tune the DistilBERT model, which is lightweight and efficient version of BERT. DistilBERT retained most of BERT performance while being faster and smaller, making it ideal for real-time application like chatbot. We fine-tuned this model using our simplified 5-emotion dataset and optimize it with the cross entropy loss function, which help minimize classification error during training. The main objective was to achieve high accuracy in emotion detection while keeping the computational cost low, ensuring that the chatbot can run efficiently even on limited hardware resources. Final phase, that is system integration, we integrated the final tune model into a chatbot framework to make it functional and interactive. When a user enters text, the system processes it through the emotion detection model, which then generates three outputs: the predicted emotion, the confidence score, and an explanation of why that emotion was detected. This design allows for transparent and user-friendly interaction, helping user understand not just what the chatbot feels, but also why it interprets the emotion that way. Overall, this integration makes the chatbot more engaging, trustworthy, and emotionally intelligent. Model performance. To evaluate the performance of our emotional classification model, we use standard matrices such as accuracy, precision, recall, and F1 square. The results showed that the model performed very well for the emotion joy and neutral, achieving the high accuracy. However, for anger and fear, the performance was relatively lower. This was mainly due to the class imbalance in the dataset, as there were fewer examples representing this emotion during the training. Despite this limitation, the overall performance of the model demonstrates that the DistilBERT can effectively recognize emotion with good accuracy while maintaining computationally efficiency. Confidence score and explainability. One of the key features of our chatbot is its ability to provide confidence score along with each emotion prediction. This confidence score represents how certain the model is about its classification. For example, if the chatbot outputs fear, that is the value of 76%, it indicates moderate, while 91% for happiness indicate high confidence. By displaying this confidence level, the system becomes more transparent and interpretable, helping user understand not just what the chatbot predicts, but also how sure it is about that prediction. This mechanism plays an important role in building user trust and encouraging responsible adoption of AI systems emotionally sensitive areas such as healthcare and education. These are some samples chatbot interaction. This slide shows some example of chatbot interprets user emotions in real conversion. In the first example, the user says, "I finally got the job I dream of." Here, the chatbot detects joy with 91% confidence, understanding the optimistic and positive tone of the message. In the second example, the user responds, why does everything always go wrong? The chatbot correctly identifies the emotion as sadness with 83% confidence, recognizing negative sentiment and word like wrong that reflect emotional distress. These examples demonstrate that the chatbot not only recognizes emotions accurately but also provides interpretable feedback, showing users how confident it is in its emotional understanding. Discussion of findings. This summarizes the key findings from our study. That is, first, in terms of feasibility, the results show that the compact model like DistillBird can deliver strong emotion recognition performance while remaining computationally efficient, making it a practical choice for real-time chatbot. However, a major challenge we observe in class imbalance, particularly for minority emotions such as anger and fear. These emotions had fear training example, we slightly affected prediction accuracy. From a transparency perspective, integrating confidence score has proven highly valuable. It helps user understand the model reasoning and increases their trust in the chatbot responses. Finally, regarding practicality, the system is lightweight and can easily be developed in resource-constrained environments such as mobile device or educational platform. Overall, this finding highlights the balance we achieve between efficiency, accuracy, and explainability. Applications of this model. This highlight that is some key real-world application of our emotion-aware and explainable chatbot. That is, in customer support, the chatbot can detect user frustration or satisfaction and adjust its responses accordingly, leading to more personalized and empathic communication. In healthcare domain, it can assist in identifying patients' emotional state through conversation, which can be particularly useful for mental health monitoring and counseling support. In education, the chatbot can adapt its tone and feedback based on the learner's mood. For example, offering encouragement when a student feels frustrated or confused. And finally, in human resources, it can be used to analyze employee feedback or survey responses to understand emotional trends within an organization. These applications show how integrating emotion recognition and explainability can significantly enhance human AI collaboration across multiple sectors.
Bali ma'am, we have 1 minute
Conclusion.
left.
Yes, ma'am. Last slide.
Mm.
To conclude, we have successfully developed an emotion-aware and explainable chatbot capable of understanding 5 key human emotions. The system effectively balances efficiency, accuracy, making it both lightweight and reliable. By integrating confidence-based explainability, it promotes transparent and trustworthy. Overall, this project lay a strong foundation for future human AI collaboration tools. These are some references which I have used. Thank you.
How we analyze the importance of confidence score and to layer the building of user trust in emotions aware of AI system.
We find the confidence score by making some precision or recall or F1 score. We have find these parameters. We have used these parameters to find the confidence score, that how chatbot detect our emotion, whether we are sad or whether we are happy.
Okay. You use the Go emotion dataset, right now?
Google emotion dataset, yes, ma'am.
Yes. So what is the main role to get the efficient and accurate the emotion classification?
We have used some sample data set that is just I have explained one example, that when the word wrong is detected, it classified that word in the sad emotions.
Okay. Okay. Thank you.
Thank you, ma'am.
Thank you so much, Bali ma'am, for your presentation. So next up we have uh, Hareswar Sarma MV presenting their work titled Jiva Rakshak 1.0 AI-driven vision-based drowsiness detection system for driver safety and accident prevention. So
Yes, ma'am.
Hareswar, are you there in the
Yes,
meeting?
ma'am. Yes, ma'am.
Yes, you can share the screen,
Yeah.
please.
Yes, ma'am. I'm sure. 1 minute, ma'am.
Yes, you can begin. You are muted.
One minute, ma'am. Am I audible,
Yes.
ma'am?
Yes, you are audible.
Hmm. Today I'm presenting our work titled Jeevarakshaka 1.0, an AI-driven based drowsiness detection system for driver safety and accident prevention. This work carried out under the guidance of Dr. P. Perumal, Associate Professor, Department of ECE. And the motivation behind this work is simple but critical: saving human lives by preventing fatigue-related road accidents. And coming to the introduction, driver drowsiness is one of the most silent and underestimated causes of road accidents worldwide. Unlike overspeeding or drunk driving, drowsiness does not give visible warnings. The driver simply loses alertness. Existing drowsiness detection systems are mostly available only in high-end vehicles, making them inaccessible to a large population. Especially in our country, we also seeing the driver drowsiness detection is usually implemented in the dashboard of cars, luxurious cars and mid-range cars. All people can't access that system, and many existing solutions depend on expensive hardware, instructive sensors, or vehicle-specific integration, which limits large-scale deployment. Additionally, several systems fail under real-world conditions such as low light, head movement, or natural driver behavior variations. Hence, there is a strong need for a low-cost and a non-instructive real-time vision-based solution that can work reliably in the everyday driving scenarios. Now, coming to the objectives of Jeevarakshaka 1.0, the primary objectives are to design a real-time vision-based system for continuous monitoring of driver alertness and to detect early fatigue indicators such as prolonged eye closure and abnormal blinking patterns. To implement the solution on a low-cost embedded platform that can be deployed in any vehicle, simply we can mount it behind the steering of the vehicle. To generate immediate alerts to warn the driver before a critical situation occurs. And finally, to develop a compact and portable and easy to install system that makes advanced driver safety accessible to everyone. And the system architecture of our Jeevarakshaka 1.0, the proposed system consists of 5 main layers. The first one, input acquisition layer. A Pi camera continuously captures real-time video of the driver's face. And the second step, processing and analysis layer. A Raspberry Pi 4B acts as the central controller. Computer vision techniques using OpenCV and Har cascade classifiers are applied to detect facial features. And the third step, driver drowsiness detection layer. Eye aspect ratio or EAR is calculated to identify sustained eye closure while filtering normal blinking. And fourth stage is alert feedback layer. Is the feedback. This is the main layer. A buzzer provides immediate audio alerts or as beep sounds, and LCD displays a real-time system status. Finally, power and deployment layer. The system can be powered using a vehicle supply or power bank. We are using now in our prototype, we are using a power bank which consists of 10,000 milliampere battery and gives the output of 22 watt power output, making it suitable for universal vehicle deployment. And control algorithms and the hardware flow. The system operation begins with initialization of the Raspberry Pi, camera, LCD, and buzzer. Video frames are continuously captured and pre-processed by converting them into grayscale and normalized frames. The driver's face is detected, followed by precise identification of eye regions. From the detected eye landmarks, the eye aspect ratio is computed to monitor eye closure duration. A threshold-based and time-based decision logic is applied to differentiate normal blinking from drowsiness. In the driver alert, the system continuously monitoring. If drowsiness is detected, the system immediately activates the buzzer and displays warning messages. This loop continues in real time until the system is turned off. And coming to the prototype and implementation, as you can see the prototype and implementation of our Jeevarakshaka 1.0, the system is built by a Raspberry Pi 4B camera, LCD display, and buzzer. The implementation demonstrates real-time facial detection, eye tracking, and drowsiness alert system. As shown in the images, when the driver eyes remains closed beyond the defined threshold, the system successfully triggers a drowsiness alert. The prototype validates both software accuracy as well as hardware reliability under real-time conditions. Results and applications. The system successfully detects drowsiness in real time with reliable performance. False alarms due to normal blinking are significantly reduced using time-based validation. And the compact form factor. As you can see, the compact form factor that can easy installation on vehicle dashboards or steering areas. The system can be especially impactful in long distance driving scenarios. And the conclusion and future scope. In conclusion, we successfully developed low-cost, real-time vision-based driver drowsiness detection system. The system accurately detects fatigue and provides instant alerts, helping to prevent accidents. Its embedded and portable design make it suitable for deployment in all vehicle types. And future enhancements. Present, we developed a version 1.0, and coming to the year, we have future plans developing 3 versions, and 2.0 comes with additional alert layer with a vibration, adding a vibration sensor, giving like a second layer for alerting system. If even driver won't get alert due to the buzzer, and immediately the second level alert vibration will be triggered. And the third version comes with a hybrid ADAS. 3.0 come with hybrid ADAS, which will be having lane detection. If the both buzzer as well as vibration fails, the car automatically, through the lane detection, the car automatically wears the left indicator and it will go to a margin and stop there itself. And this Jiva Rakshaka can contribute significantly to road safety and accident prevention. Thank you for all your time. I will be happy to answer any questions. Thank you.
Okay, Harishwa,
Ma'am.
what are the challenges and limitations of implementing the vision-based drowsiness detection system?
Ma'am, the challenges we initially faced were the camera position. While we did a trials in our university by our university bus drivers. The main problem is that we present in the design. Can I show the design, ma'am? Can I show my product?
Yes, please.
1 minute, ma'am. This is the Jiva Rakshaka product, which can be mounted directly behind the steering, ma'am.
Okay.
Coming to the first challenge is, while we went for survey, the
Have you
camera.
implemented this?
Yes, ma'am.
Okay.
Present, I didn't given the power. Here, the power system. Wait, I give the power. The system will automatically on. These are two IR filters for night vision. The problem is fixed camera position. If we will mitigate the problem by doing changes in design. We can fix the camera. We will change the angles of the camera. And second problem is the distance between the driver seat and the steering and the product. Present, we are using OmniVision 5 megapixel camera. So the camera megapixel is not able to detecting the long range of the driver's face. So later we will implement the high megapixel camera to detect, or else we will use the machine learning algorithms for auto focusing the head position of the driver.
Okay.
That's the two problems we faced, ma'am.
Okay.
Okay.
Nice. It's good.
Thank you,
Any
ma'am.
questions, ma'am?
No, thank you.
Thank you. Thank you for giving this wonderful opportunity, ma'am.
Okay, so our next presenter is Martin Michalovic, who are here to discuss their work titled Real-Time Recognition of 3D Identifiers in Mixed Reality Environments. So, Martin, are you here?
Yes, hello, good afternoon.
Hello, good afternoon. So, you can share your screen and begin your presentation.
Sure. Okay, can you see my screen?
Yes.
Okay, perfect. So, good afternoon, ladies and gentlemen. My name is Martin Michalovic, and I'm from the Faculty of Electrical Engineering and Information Technology in Bratislava, Slovakia. Today, I will present our paper titled Real-Time Recognition of 3D Identifiers in Mixed Reality Environments. I've split the presentation into 4 parts, starting with motivation. Augmented reality and mixed reality are closely connected with the concept of Industry 4.0, where the main goals are to optimize production processes and better respond to market changes. The use of AR helps employees improve their productivity, efficiency, and safety at work. A typical example can be use of AR glasses, where the employee can see a real-time information in their field of view, such as work instructions, repair manuals, current state of devices, or can be also used for interactive training. To display such virtual elements in real time, AR application use different tracking and recognition approaches. One of the most common is marker-based AR. It means that system use unique high contrast geometric patterns as reference points for the camera. Typical examples are graphic markers, codes, or barcodes. However, there is several limitations, especially in industrial environments. Recognition can be negatively affected by motion blur, poor lighting, or strong reflections. Also, in dusty environments, markers can become dirty or physically damaged. Disadvantage can also be their planar localization and tracking, or the ease of decrypting or copying them. To address these limitations, we proposed the use of 3D identifiers as innovative solution for object identification and localization in mixed reality environments. The goal was to design an object, the identifier, which is not only recognizable by AR systems, but also suitable for 3D printing. The advantage can be the possibility of scanning from any angle and different distances. They can also be useful for identical entities if they have a similar or same physical shape or are dynamic. And with a practical example of their application in logistic and warehouses where QR codes are commonly used. About the identifier design, at the beginning, it was necessary to define what properties the identifier should meet. We decided it should be able to carry information. The question was how to make designs so that it can include ID or any key information. Then we defined that generated design should reflect such coded information. It should also be suitable for 3D printing, and last but not least, it should be recognizable. So we designed the appearance of identifier in the shape of cube. ID is entered by user as numbered string of at least 7 digits that is converted into a format that can be interpreted as 3D shape. In our case, the numbered string is converted into square system where each bit is from the range 0 to 3, and each number from this range is represented by one basic element you can see here. Our program is coded in Python script in Blender environment that then places together these basic elements to the scene, creating a cube identifier as you can see in the picture. Later, it is exported as STL file from Blender, which is a standard format suitable for 3D printing. In our laboratory, we use this 3D printers Prusa for additive manufacturing. And as you can see in the picture, we were able to print several identifiers which were later used for recognition. About the recognition application, the recognition application itself was built using Unity together with Vuforia engine for object recognition. The main idea behind the application is simple and practical. After launching the application, the user loads a database containing all expected 3D identifiers, And when a physical identifier is placed in front of the camera, system recognizes the object in real time and matches it with the corresponding model from the database. The application also displays the recognition time, which is shown in upper right corner of the screen. To train or for training, it takes place in the model target generator provided by Vuforia. In this step, the previously generated identifiers are uploaded to the system. For each identifier, we define basic rules and parameters that guide the creation of the database. Essentially, we upload the STL file of the object and software processes them so they can be recognized in real time. On the slide, you can all see examples of STL objects loaded into model target. To validate our approach, we subjected the 3D printed identifiers to recognition tests. Each identifier was assigned with a unique name, which is displayed in the upper left corner of the screen when the system successfully recognizes it. Pictures on the slide show a preview of setup in our laboratory, where we hold the device running the recognition application in our hand. In the picture, you can also see the information about successful recognition. In addition to laboratory tests, we also conducted recognition tests in external warehouse as well. The goal of this testing was to evaluate how well the system performs under real-world conditions, including different lighting distances and backgrounds. What leads us to the evaluation. Our results showed that the identifiers were successfully recognized in real time as well, confirming that the system is robust and practical beyond laboratory conditions. When testing in external environments, we observed an increase in recognition time ranging from 17 to 22% compared to lab conditions. But this increase is due to lighting, reflections, and background interference, which are common challenges in the real world environment. Nevertheless, the system demonstrated stable behavior with standard deviation values remaining below 0.15 seconds for all test objects. And about printing costs, it took around 1 day and 17 hours using 195 grams of filament to print such objects. About size, that's also matter about size 10 centimeters. Thank you very much for your attention, and I'm ready for your questions.
Yes, Martin, am I audible?
Yes,
Yes. What are the 3D identifiers you have used and how to overcome the limitations of the traditional markers?
Pardon, can you please repeat the question?
What are the 3D identifiers are used in the traditional fiducial marker in 2D matrix code in the environment?
Uh, um, our goal is to replace the 2D markers or use our identifiers as modern innovative solutions in the industrial use where the traditional markers can be, as I mentioned, damaged or easily copied or decrypted.
Okay. What is the role of Unity in the design and implementation of the proposed 3D identifier recognition system?
We use Unity because of the possibility to launch and install applications for the different platforms such as Android or iOS devices. We tried both, and it worked for the both platforms.
Okay. Okay. That's good. Thank you.
Thank you as well.
Okay. Anybody from Amir's team is here in the meeting? Dr. Srivastav or Chitransh? Anybody ready for the presentation from Amir's team? I'm able to see Dr. Vishal Srivastav and Chitransh from Amir's team. So are they ready, Amir? Amir is
Hello,
here, I
yes,
think.
yes.
Can you share the screen and present the presentation? I hope you have resolved the issues.
I have, yes, I have a issue
You have
connecting in
resolved
network
the
issue.
issues. So it
I
is,
try.
you can try to present the screen, or else anybody from your team can try to present the presentation.
Oh, sorry, I have network issue. I'm audible. Hello,
Yes,
can I share my screen?
yes.
Okay, just a minute.
You can
Okay,
begin with the presentation. It is visible.
yes. What is the problem? Okay,
Just share the screen, Amir. Yes, you can start.
oh, sorry, I see the screen and in my screen.
Okay, you can start orally.
Okay, oh, sorry for the inconvenient for the network issue. So good afternoon, everyone. My name is Amir Khan. I present my presentation on the behalf of my team. Our research paper code is 5, and my topic is building responsive UI UX, using
Voice is
relevant
not
CSS
audible.
and React.
Yashita?
Amir, can you stop
Not
sharing
audible?
the screen so that you can, your network will be stable? You can stop sharing the screen, please.
Okay.
Now you can speak.
I'm audible.
Yes.
Now I present my presentation or share my screen with my
No,
screen.
you speak orally.
Okay. So, okay. Building responsive UI UX in the full stack applications, relevant CSS and React. This is a combination of creating the industrial standard for the building scalable, high performable, and web applications. The device density, we not no longer in living in the world just for desktop versus mobile. We must the account for the smartphones, tablets, large desktop monitors, and even emerging wearable technologies on the business impact, mm, embroidered on the consistency or not responding UX. This is not just a authentic issue. It's a business issue. If the applications fail to adapt to it, lead to high bounce rate and low user enhancement. Now the benefit of the responsive UI go through each row and the tables. Cross-device compatibility. The goal is consistency, usability. Just a minute. The button must
I
be
think he's just
easy.
reading the
Okay.
sentences, Yashita.
Okay. What, ma'am? Hello.
Okay, just give me the summary. Just give me the summary, Amir.
Okay, summary.
I didn't get you what you have to be explain yourself. Just give me the briefing or the summary
The
of your
summary.
project.
Okay. Just a minute. The summary is the code. The Tailwind CSS and the React is not accelerate the development process, but also ensure the scalable, maintainability, and performance. That's it.
Okay.
Okay, thank you.
Okay, I understand.
I have
Okay, so with this, we come to the conclusion of the technical session 4E. So I would like to sincerely thank all the authors for their excellent presentations and their contributions. So your work will truly reflect the spirit and the quality of ICTCS. I would also like to thank all our participants for staying with us and making this session engaging and interactive. So this marks as the 10th edition of ICTCS, and we are very grateful for your support, not only this year, but throughout all the previous editions. And we all look forward to welcoming you again for the 11th edition in 2026. So a few important updates before we conclude. So all presenters will receive their digital certificates within 2 working days through their emails, and the publication process will be completed within 7 to 8 months. And we request your cooperation with the ICTCS team during this period of publication. So I would like to extend a very special thank you to our session chair, Dr. Ishwari Raskar ma'am, for guiding today's session very gracefully and for sharing their valuable expertise. So this certificate is a small token of appreciation on behalf of our team ICTCS 2025 and the Global Knowledge Research Foundation and partners. So before we officially conclude, I will request everyone to please switch on their cameras so that I can capture this moment together. So everybody, please can you switch on the cameras?
Thank you so much, Yashita, for giving me the opportunity, and I
Thank
appreciate
you
all
for
the
being
authors
with
and
us.
presenters. Yes.
Everybody, Kushank, Samarth. Everybody on the camera, please. Okay. So before we officially conclude, thank you all for your valuable presence. Take care, and we look forward to seeing you in the next session as well.
Thank you.
So
Thank you.
thank you. Thank you, everybody. Thank you, Ishwari ma'am.
Sorry,
Yes,
ma'am,
thank you.
for the network issues.
Yeah,
No
that's
worries,
fine.
it's okay. Fine. Chalo, bye bye. Take care, all of you.
That's